7,800 satellites, each one circling the whole planet, waiting to dive down and smash a nuclear missile in the first 3 minutes after launch. The price? $1.2 trillion. And here's the line nobody in Washington wanted to say out loud. By the government's own math, all of it could stop about 10 missiles. 10, not 10,000. 10. How do you build one of the largest satellite fleets ever imagined, spend $750 billion, and still stop only about 10 missiles? This isn't a budget mistake. It isn't a bad contractor. It's physics, the same physics scientists flagged back in 2003. But that's not the strangest part. 2 seconds on who's talking. I'm Andrew. This is Signal Tomorrow, and the channel runs on one question. Does the engineering behind a headline actually hold up? Subscribe if that sounds like you. Golden Dome, then, what it actually is. Golden Dome is President Trump's plan to build a shield over the entire United States, one that catches ballistic, hypersonic, and cruise missiles before they reach a single city. The centerpiece sits in space. A constellation of those 7,800 interceptors, plus tracking satellites and orbiting data centers, all in low Earth orbit, all wired into an AI brain that decides in seconds what to shoot. If it sounds familiar, it should. We've reached for this exact idea once before. Reagan tried this in the 1980s. His Star Wars program imagined thousands of tiny orbital kill vehicles called brilliant pebbles, meant to swat Soviet missiles out of the sky from orbit. The 90s shelved it as science fiction. Golden Dome is that same dream, resurrected with modern rockets and cheap launches. And if you pay federal taxes, this trillion-dollar bet is your bet. Your money, on the table. This moved fast. On May 20th, 2025, Trump unveiled Golden Dome, a finished shield in about 3 years, he said, for $175 billion. Experts called the timeline fantasy. They were right. Within a year, the Pentagon's own estimate had crept to $185 billion. Then the Congressional Budget Office, Congress's nonpartisan scorekeeper, showed up with a number 7 times bigger. So how do you actually shoot a missile down from orbit? You hit it at its weakest moment. Every missile has a boost phase, the 3 to 5 minutes right after launch, while the rocket engine is still burning. In that window, it's slow, it's clumsy, and it's lit up with a heat plume you can see from space. Best of all, it's still one object. The warheads and decoys haven't split off yet. Kill it there, and you destroy everything it carries in a single shot. No sorting real warheads from fakes. No chasing a dozen decoys across the sky. That's the whole appeal. To pull it off, the interceptors ride low, around 300 to 500 kilometers up, close enough to drop onto a booster fast. A separate fleet watches for launches and calls the shot. 108 satellites down low, 27 higher up. Right. Speed is everything here. A booster burns for 3 to 5 minutes, then it's gone. That's the entire window. Spot the launch, confirm it's real, pick the one satellite actually in range, and fire. Automatically. Faster than any human could sign off. That's why Golden Dome leans on an AI command network and data centers in orbit. The whole thing lives or dies on software, making a life or death call in seconds. Here's the strange part we promised. Satellites don't hover. They can't park over an enemy silo and wait. They race around the entire Earth about once every 90 minutes, which means at any given second, most of your fleet is on the wrong side of the planet. To guarantee just one interceptor is overhead above a single launch site, you don't need one satellite. You need around 950. Todd Harrison studies this at the American Enterprise Institute, a think tank, and he puts it bluntly. Quote, they're orbiting the Earth about once every 90 minutes. So if you put one interceptor up there, what are the odds it's in the right place? 950 satellites for one silo. 1,900 if 2 missiles fire at once. Run that out to a real war, and 7,800 satellites suddenly looks very small. Remember that number from the very start? This is where it comes from. The CBO ran the numbers and found the whole 7,800 satellite shield could engage only about 10 near-simultaneous ICBMs. Intercontinental missiles. Russia and China could launch far more. In the CBO's own careful words, it would not be an impenetrable shield. 10 missiles. $743 billion. Read that again. $743 billion buys just the interceptors, about 60% of the whole program. The reason it never stops costing. Each satellite runs around $22 million and lasts only about 5 years before atmospheric drag pulls it down and burns it up. They're perishable munitions. To keep 7,800 alive for 2 decades, you'd have to build and launch roughly 30,000 of them. That's about 1,600 new satellites every single year. But not everyone buys that trillion. The Pentagon's own pitch is about $185 billion. 1/7 the size. The program's lead, Space Force General Michael Getline, flatly rejected this CBO number. Quote, "They're not estimating what we're building. You can't just take what we've done in the past and multiply it forward. Maybe, but the other reading is worse. Either the shield is far smaller than promised, or the money's buried in budgets nobody will show." Now who cashes in? In April, the Space Force named 12 companies to prototype these interceptors. Anduril, Lockheed Martin, Northrop Grumman, Raytheon, and SpaceX among them, with a hard deadline. Demonstrate a working space interceptor by 2028. The biggest early winner is Elon Musk's SpaceX. In 4 days last May, it landed 2 contracts for the tracking and data backbone worth about $6.5 billion. And this is where it gets uncomfortable. The man who used to run America's homeland missile defense, Terrence O'Shaughnessy, now works for Musk at SpaceX. So the government's biggest space contractor is partly steered by the person who once ran the very mission it's bidding on. Meanwhile, the lawmakers who paid for all this say the Pentagon still won't tell them how $23 billion is being spent. It's not just Americans watching the price tag. Russia and China have already called Golden Dome destabilizing, because a shield that might blunt a retaliation strike quietly rewrites the logic that's kept nuclear peace for decades. Part of the constellation reportedly leans on new basing in Greenland, at Pituffik. So a project sold as a wall could end up dragging allies in and starting the next arms race. This is where we land. Golden Dome is a bet that you can outbuild orbital mechanics, that enough money and enough satellites can beat a wall of physics the physicists' own professional society called a dead end back in 2003. Nothing about that physics has changed. And there's a darker wrinkle. A shield this leaky doesn't fail quietly. Analysts warn it could tempt an enemy to strike first before the constellation fills out. A defense that makes war likelier. Look, the appeal is real. Boost phase intercept, if it truly worked, would be the holy grail of missile defense. But Reagan's engineers hit this exact wall 40 years ago and walked away. What's different now isn't the physics. It's the politics and a launch industry hungry for the contracts. 2028 is the moment of truth. Vendors have to put a real interceptor in orbit and prove it can actually kill something. Can 7,800 satellites stop a nuke? On paper, a handful. In a real war against a peer, the government's own numbers say no. Golden Dome may be the most expensive way yet devised to spend $750 billion and still leave the front door wide open. Whether the 2028 demo changes that, or just raises the bill again, we'll be watching. If this made the trillion make sense, a like genuinely helps us out. Subscribe for more like it, and I'll see you in the next one.